Morning, everybody. We're going to finish up the last section of our unit here. The plan is that we're going to have a test next Thursday. So I'm going to include some review problems on Canvas today if you want to go ahead and get started reviewing. But basically all of chapter 12 from that red book is going to be in there, and all of chapter 15 from the orange book is going to be in there. So all of those basic statistics, and as well as the normal distribution. So kind of going into today, the first thing is that, so when we've calculated normal distribution so far, so last class when we were calculating them, we only considered numbers that are a whole standard deviation away, that were one standard deviation or two or -1 or -2. But what we're going to look at today is that we're going to be looking at the decimal approximations. So in this class, we're going to be using calculators to figure out the decimal ones. And so we're going to use that. We're going to do that with a function on there that's called the normal CDF. Now, what the normal CDF does is it stands for the normal cumulative distribution function. So basically with any normal function, it's going to accumulate between two data points in a normal distribution. And so we're going to look at what that looks like. I'm going to use the TI or the Graphin Calc 83 app on the calculator. If you have a TI 83 or 84, it should roughly be the same thing. If you're using the TI Graphin Calc 83 app, you can just hop in and follow along here. So basically what we're going to look at today is when we're trying to calculate things that are not perfect z-scores. So we've got the variable x here is normally distributed with a mean of 40 and a standard deviation of 10. And so what we're going to do is we're going to find a couple of different things. So the first thing that we're going to do is find the percentage of things that are between 37 and 48. X is between both of those things. So I'm going to draw a curve just to illustrate what exactly we're finding here. So as a reminder, the mean is the center. The standard deviation is one step away. 30 and 20, and we typically go out 3 in each direction. So what we want to know is what percentage is between 37 and 48. We want to know what this chunk of this graph is, if the whole curve is 100%. So basically what we're going to do here, we're going to pull up this graphing calculator here. So right here where it says distributions, that's what we're going to be looking for here. So to access that, and if you want to take a second, write these steps down, that's fine. If you go to second and distribution there, it's going to pull up a whole list of distributions that we haven't talked about yet. The only ones that we've talked about so far, we've talked about the normal CDF right there. So we're going to click normal CDF. So to calculate this thing, we're going to say normal CDF parentheses. Now on this one at least, it tells you the order of things to put it on. I don't know for a regular calculator if it will pull that up or not. But the first thing we want to put in is the lower bound. So what is the lower data point that we need? Here it is 37. So I'm going to say 37, and it says we need a comma there. For 48, we're going to put 48. We're going to put a comma there, and then it wants the mean, and then it wants the standard deviation. So for this problem, the mean is 40. The standard deviation is 10. And we calculate that. So I'm going to write down over here what we wrote in the calculator. So we did the lower bound of 37, we did 48, we did 40, and we did 10. And there are ways to calculate this by hand. Every percentage away has a number associated with it. But in this course, they only want you all to use technology to do so. So depending on what class you're in, you may have to do it by hand. My statistics class is required to do it by hand, but for IBAI, they do not require you all to do it by hand. So this region that we shaded in here is roughly about 40%, which if you're looking at that curve from last class and you're like, oh, okay, that kind of makes sense because we got a little bit of that 34 in there. We got a little part of that other 34 in there. But cumulatively, if we add all that stuff up, it's going to be about 40.6% of that curve out of 100%. So then the next one that we want to know, so same standard deviation, same mean, but we want to know how many are going to be greater than 45. So again, I'm just going to draw a curve just so that we know what it is that we're finding percentage-wise. I think looking at things from multiple point of views is a good thing. So 45 occurs between 50 and 45 here. So we want to know what percentage is to the right of this thing right here. So when we write this normal CDF here, we've got to write the lower bound and then the upper bound. So the first, for the lower bound here, the lowest number we're going to calculate here is 45. So we're going to write in 45, comma. Now for the upper bound, this keeps going further and further to the right. Like if you look at an actual normal distribution, there's arrows here, which means that these go on for forever. So what we need to do is we just need to put in a really large number. So typically, I just use 10 to the 99th power. That's going to give you a very, very large number. It's not quite infinity, but it works. And we're going to say a mean of 40, a standard deviation of 10. So again, to hit that, if you hit second and you go to distribution here under vars, we're going to normal CDF. We're going to do 45, comma. That's the lower bound. The upper bound is 10 to the 99th power. That's a very large number. We're going to do 40, and then we're going to do a standard deviation of 10. So if you evaluate that, that's approximately 0.3. We're going to round that up to 0.309, or 30.9% of observations here are greater than 45, given what we know. And so then, if we've got a less than, it's going to be the same type of thing here, where we've still got the mean, we've still got this same old curve, 30, 20, and 10. We want to figure out 26, so roughly right there. We want to know how much of this curve is to the left of it. And so now with the normal CDF, what we're trying to figure out, the normal cumulative distribution function, the lower bound here, the furthest left we can go, we've got to put in this one of the smallest numbers that we can get here. So I like to use 10 to the negative 99 for the lower bound. And then the upper bound is just going to be as high as it gets. So here it's going to be 26. And we're still going to use 40. We're still going to use 10 here. And what that's going to do is it's going to add up the probability from the furthest left we can get all the way up to 26. So again, I'm going to hit second. I'm going to hit vars. Go to normal CDF. 10 to the negative 99. That's our lower bound. Our upper bound is 26. We've got 40 as the mean. We've got 10 as the standard deviation. And it's going to add those together. So we're going to call that approximately 0.081 or 8.1%. Those are that's the percentage of things, of observations that are less than 26 in this normal distribution. And so that's the first thing that we're going to look at today is just if it's not a whole number, we cannot use the 68, 95, 99, 7 rule. because those we end up splitting those percentages unevenly. So if it's a decimal, we can use just the normal CDF function on your calculator to evaluate it. So that's the first thing that we're going to look at today. Now, the next thing that we're going to look at is going to be something called a quantile. So kind of to set the stage for what a quantile is. So we're going to do a hypothetical here to lead into our example. So consider a population of crabs where the length of a shell is X millimeters. Now, since it's a population of crabs, it is going to be normally distributed. There's a bunch of factors that go into the shell length of a crab. And so we're saying it's normal. It has a mean of 70 and a standard deviation of 10 millimeters. So now, a biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. So in other words, he's going to be protecting the bottom 95%, or what we call the 95th percentile. So what we need to figure out now is, well, what number, what raw data point is going to correspond to the 95th percentile? Or in other words, we want to find K such that the proportion of observations that's less than K is 0.95 or 95%. So this number K that we're referring to, that is called a quantile. It is what number do we have to meet this certain percentile? What quantity do we have to meet to be at this certain percentile? Now, kind of the mindset that we need to think of here, so that when finding quantiles, we're given a probability and we're asked to find the corresponding measurement. Whereas before, we were given the corresponding measurement and we were asked to find the probability. So effectively what we're doing is we're doing the inverse of finding probabilities. So when you're doing the opposite, we're going to use what's called the inverse normal function. We're going to do the inverse normal function, which again, we're going to use a calculator for. But to start off here, kind of to set the scene here, a population of crabs, so we're using this crab example, has a shell length of X millimeters. And we're saying X is normally distributed, it has a mean of 70 and a standard deviation of 10. And we want to know what would constitute the 95th percentile. What would be, so 70, we've got 80, 90, 100, we've got 60, we've got 50, we've got 40. So this whole curve right here adds up to 100%. All of the observations under a normal distribution cover all of the possibilities here. So what we've got to do is find the number here for K that would make it the amount to the left 95%. So to do that, again, we're going to be using a calculator here to evaluate the inverse ones. So if you go back to distributions, you hit second vars or second distributions. Right here where it says inverse norm, that's the inverse normal distribution. So what you've got to do here, the first thing is you've got to put in the area that you are trying to find. So the area under the curve that we are interested in here is 0.1, or not 0.1, 0.95. 0.95. And we're going to say, okay, well, that 0.95 there, it has a mean of 70, a standard deviation of 10. And what this is going to do is it's going to generate a data point based off of this for us. So the data point here is going to be 86.448, and that will be millimeters. Now, if you think about what we looked at last class with the percentiles, the 34s, the 12s, the 13-ish, the 2s, What we saw was that if you're one standard deviation away, this was like 34%. So we are here at 86.448. So it's saying at this point right here at 86.6 or 0.448, excuse me, all the way to the left. So we include this 34, this other stuff. If you shade in all of this information right here, that is approximately 95% of your normal curve. So again, let me go ahead and write down what function we wrote. So it was the inverse normal distribution. The area we were trying to find was 0.95 with a mean of 70 and a standard deviation of 10. So then we're going to look at one more example and we'll call it a day for today on the notes. So we're going to suppose X is normally distributed here with a mean of 20 and a standard deviation of 3. We want to illustrate with a sketch and find K such that these conditions are met. So the first condition is that the proportion of observations is that are less than or equal to K is 0.3 or 30%. So again, I'm going to draw a curve here. So this curve is 20, we've got 23, we've got 26, we've got 29. And really all that the curve serves to do is to keep it in perspective. Okay, does the answer that I ended up with make sense? Does it look like it's about 30% of the curve? So I'm going to write out this function real quick. The inverse normal distribution, we're looking for 0.3. We have a mean of 20 here, and we've got a standard deviation of 10. So let's see here, if I hit second distribution, we're going to inverse norm, 0.3, comma, 20 is the mean, 10, we're going to close that, and that gives us approximately, oh shoot, I messed up. Sorry about that. The standard deviation is not 10 anymore. It is 3. I was thinking of the last problem. So that's going to give us a data point. So K here is going to be 18.4267. So again, what we're finding here, that's going to be like approximately halfway in between. So we're saying from here to the left side right here is 30%. This area under the curve, since this is a normal distribution, is 30%. Now, for the last problem here, for these greater thans right here, we need to note something. So at least on the calculator that I am using right now, the inverse norm calculates less than proportions or percentages. So depending on the calculator that you have, it may have the capability to do greater thans. But basically what we have to do is say, okay, if the probability of observations of X that are greater than K is 0.2, since my calculator only does less thans, I'm going to rewrite that such that we're going to say, well, that means that the amount that are less than K, so if the amount that are greater than K is 0.2, the amount that are less than K is going to be 0.8. And this is the fact that I'm going to use because the calculator I'm utilizing can only do less thans. So I'm not sure exactly which ones can do which. I haven't had a chance to look into that a ton, but we can talk about that a little bit more as we run into that issue. So again, we're going to write a function here. We're going to do the inverse normal distribution with an area of 0.8, a mean of 20, and a standard deviation of 3. So if you hit second in distribution, we go to inverse norm. We're going 0.8, comma, 20 is the mean. The standard deviation is 3. And that's going to give us a data point of 22.52. Which again, kind of to set the idea for what it is that we're finding with these normal distributions. The mean here was 20. And we had the standard deviation of 3. So 23, 26, 29, 17, 14, 11. We claim that at 22.5, so like here-ish, if you go to the left-hand side, that this is 80%. And if you go to the right-hand side here in pink, that this is 20% of the curve. And again, you can look at that empirical rule and double check that. So this is all of the information that I have for you all for this next unit. So again, we do have our next test next Thursday. So I'm going to have review problems posted as well as some problems from here. You all, in doing that first review for Chapter 12, doing 12A, should have a head start on that. But if you all have any questions on the content from today, please shoot me an email. Please meet with me on Zoom and we can get you squared away. Thanks. Bye.